Sometimes when we are given a differential equation, we're given additional information that we also want to be true. And this helps us figure out which of all the various C's, constants that we have that tend to pop up in these differential equation solutions, we want. For example, let's say we want the derivative of our function to be the original function cubed divided by x, and we also want f of 1 to be 1/2. Well, we hold the initial, and so this is called the initial condition. This is the initial condition. We're going to hold this until later and plug in that information once we have a solution, because basically it's saying, well, f of 1 is 1/2. So what have we got? We take dy dx is y cubed over x. We replace everything. We try to separate it. How do we do that? We bring the dx up and the dy cubed down, and we get 1 over y cubed dy is equal to 1 over x dx, which is y to the negative 3 dy equals 1 over x dx. And then we integrate both sides now that we have all the y's on one side and all the x's on the other. And this becomes y to the negative 2 over negative 2 plus a constant is equal to the natural log of the absolute value of x plus another constant minus that first constant is just a constant. And what do we do with this? What do we do with this? Maybe move the negative 2 over. So y to the negative 2 is negative 2 natural log of absolute value of x plus negative 2 times a constant is just a constant. And what is this? This is 1 over y squared is negative 2 natural log absolute value of x plus c. I guess I can bring the y squared up and that down and get, and I'm going to call this 1 over c minus 2 natural log absolute value of x is y squared. I'm going to see if I can get some more room in here and say y is plus or minus the square root of 1 over c minus 2 natural log of absolute value of x. Now this is the most general solution. This is, well, why don't I write it in terms of f of x? F of x is plus or minus, well, the square root of 1 is just 1, so I could call it 1 over the square root of c minus 2 natural log of absolute value of x. Well, that's great. That is all the possible things that make that true. But how many of them have f of 1 equals 1/2? So here's where the initial comes back in. The initial condition comes back in. F of 1 is 1/2. Well, let's plug in that information. That means that we want f of 1, which is plus or minus this 1 over the square root of, we're plugging in 1, c minus 2 times the natural log of absolute value of 1. Hey, natural log of the absolute value of 1 is the natural log of 1, which is 0. And 0 times 2, it's gone. So basically what we're saying is plus or minus 1 over the square root of c has got to be 1/2. And so this means two things. One, c must be 4, so that the square root of c will be 2. And 2, it must be plus. If I had said, oh, I want f of 1 to be negative 1/2, then it's going to have to be negative. So that tells me that we don't have this most general solution. We have f of x has to be plus 1 over the square root of 4 minus 2 natural log of the absolute value of x. And this is the most general solution. It has the initial requirement, which was what? The derivative is the original function cubed over x, and f of 1 has to be 1/2. Well, certainly f of 1 is 1/2 because this goes away and you get 1 over square root of 4. That's 1/2. I don't feel like verifying this, but I'll bet you if you took the derivative of this, you would get that thing cubed divided by x. Whew. You really want me to check it? Okay, but this is the last one. This is the last one. What is the derivative of this? The derivative of this is, oh, what is that? I'm going to call that 4 minus 2 natural log of absolute value of x to the negative 1/2 power. So the negative 1/2 comes out front. We leave the 4 minus 2 natural log of absolute value of x for a second. Let's see, it was to the negative 1/2 power, now it's to the negative 3/2 power, and we multiply by the derivative of what's inside. The derivative of 4 is nothing, and we get negative 2 over x. That's the derivative of the natural log of x. So this negative 2 cancels out with this negative 1/2, and we are left with, I'm going to write it just this way. I'm going to write it as, there's the x down below, and I'm going to call this 4 minus 2 natural log of absolute value of x to the negative 1/2 cubed, because when you raise an exponent to an exponent, you multiply, there's your negative 3/2. This thing inside, hopefully you recognize, is this thing. So that is, in fact, f of x cubed over x, just as we wanted it. So this is the solution to the differential equation. Differential equation with the additional requirement. The most general thing, if we had gotten rid of this, then the answer would be this. But if you want to have the initial condition of f of 1 is 1/2, then it specifically has to be, c has to be 4, and it has to be positive.